Places A and B are 100 kilometers apart on a highway. One car starts from A and another from B at the same time. If the car travels in the same direction at different speeds, they meet in 5 hours. If they travel towards each other, they meet in 1 hour. What are the speeds of the two cars? We thought of adding a small twist to this one. We have hidden the steps required to solve this word problem sequentially inside a Matryoshka doll set, a set of wooden dolls of decreasing size placed one inside another. We begin with clue number 1, that is step number 1, and the correct solution to clue number 1 or step number 1 will allow us to see the figure, open the wooden frame and access clue number 2, that is step number 2, and so on till we complete all the steps and reach our solution. Let's begin with clue number 1 or step number 1. Figure out or identify the unknown parameters. What is the question asking us to determine? Yes, the speeds of the two cars. Let us denote them with the variables x and y. Speed of the car that starts from place A, let us call it car A, is equal to x. Speed of the car that starts from place B, let us call it car B, is equal to y. Note down the units. With respect to this question, the distance is given in kilometers and time is mentioned in hours. So the unit for speed of each car will be kilometers per hour. With this, step number 1 is complete. We can now see the figure, open the wooden frame and access clue number 2. Clue number 2 or step number 2 is form a pair of linear equations. Which statement from the question can we use to form our first linear equation? Yes, if the car travels in the same direction at different speeds, they meet in 5 hours. Let us visualize this scenario to understand it better. Let us imagine both cars are moving towards our right side. Car A begins from place A and car B begins from place B. For them to meet after 5 hours, car A must run at a speed higher than that of car B. To be able to catch up with it, let's say at a place called C. After 5 hours, car B would have travelled up to C. Car A was able to cross place B and catch up and meet car B at place C. As it was running at a higher speed, it was able to cover more distance than car B in the same span of 5 hours. Now let's try and form the equations. For car A, distance d1 is equal to speed of car A into time, which implies d1 is equal to x into 5, which is equal to 5x. For car B, distance d2 is equal to speed of car B into time, which implies d2 is equal to y into 5, which is equal to 5y. We will think in terms of distance as we know the distance between place A and place B, that is 100 kilometers. If you look at the diagram carefully, the difference between the distance covered by car A and car B in 5 hours is equal to 100 kilometers. That is, the distance travelled by car A minus the distance travelled by car B is equal to 100 kilometers. Therefore, we can write it as d1 minus d2 is equal to 100, which implies 5x minus 5y is equal to 100, which implies 5 into x minus y within brackets is equal to 100, which implies x minus y is equal to 100 upon 5, which implies x minus y is equal to 20, which implies x minus y minus 20 is equal to 0, giving us our first linear equation. As an alternate, we can also use the concept of relative or effective speed involving two independent objects moving in the same direction to form the equation directly using the formula distance is equal to relative speed of objects into time, wherein relative speed of the cars will be equal to the difference of the speeds of the cars moving in the same direction, that is x minus y, and time will be equal to 5 hours, which would give us which implies 100 upon 5 is equal to x minus y, which implies 20 is equal to x minus y, which implies 0 is equal to x minus y minus 20. On swapping both sides, we get x minus y minus 20 is equal to 0, which is our first linear equation. Now, which statement from the question can we use to form our second linear equation? Yes, if they travel towards each other, they meet in 1 hour. Let us visualize this scenario to understand and remember it better. Car A begins from place A at a speed of x kilometers per hour, and car B begins from place B at a speed of y kilometers per hour. After 1 hour, they meet. Now let us try and form the equation. For car A, distance d3 is equal to speed of car A into time, which is equal to x into 1, which is equal to x. For car B, distance d4 is equal to speed of car B into time, which is equal to y into 1, which is equal to y. Therefore, we have distance d3 is equal to x and distance d4 is equal to y. If we look at the diagram carefully, the sum of the distance covered by car A and distance covered by car B in 1 hour is equal to 100 kilometers. Therefore, for this scenario, we can write it as d3 plus d4 is equal to 100, which implies x plus y is equal to 100, which implies x plus y minus 100 is equal to 0, our second linear equation. As an alternate, we can also use the concept of relative or effective speed involving two independent objects moving in the opposite direction or towards each other to form the equation directly using the formula distance is equal to relative speed of objects into time, wherein the relative speed of the cars will be equal to the sum of the speeds of the cars moving in the opposite direction or towards each other, that is x plus y, and time will be equal to 1 hour, which would give us distance is equal to x plus y within brackets into 1, which implies 100 is equal to x plus y, which implies x plus y is equal to 100 on swapping both sides, which implies x plus y minus 100 is equal to 0 in the standard form, which is our second linear equation. Once you understand the concept of relative speed or effective speed involving two independent objects moving in the same or opposite direction, you can directly form the equations to save time. With this, step number 2 is complete. We can now see the figure, open the wooden frame, and access clue number 3 or step number 3. Step number 3 is solve the pair of linear equations using a method of your choice. We have the equations x minus y minus 20 is equal to 0 and x plus y minus 100 is equal to 0. Let us go with the elimination method. Since both the coefficients of x and y are 1, if we add equations 1 and 2, we'll be able to eliminate y easily and figure out the value of x. Adding equations 1 and 2, we have x minus y minus 20 is equal to 0, x plus y minus 100 is equal to 0. X plus x will give us 2x, minus y plus y will give us 0, minus 20 and minus 100 on addition will give us minus 120 is equal to 0 plus 0, 0, which implies 2x plus 0 minus 120 is equal to 0, 2x minus 120 is equal to 0, which implies 2x is equal to 120, which implies x is equal to 120 upon 2, which is equal to 60. Using this, we will find the value of y. Putting the value of x in equation 2, we have x plus y minus 100 is equal to 0, x plus y is equal to 100, which implies 60 plus y is equal to 100, which implies y is equal to 100 minus 60. which implies y is equal to 40. Therefore, we have figured out the values of both x and y. With this, step number 3 is complete. We can now see the figure on the wooden doll, open the wooden figure or frame and access the final clue for this problem. Step number 4 is, or clue number 4 is, state the answer with correct units. Our solution to the problem. X is equal to speed of car A, which is equal to 60 kilometers per hour, and y is equal to speed of car B, which is equal to 40 kilometers per hour. For those of you who are wondering if you will get to see the remaining figures in the Matryoshka doll set, we present to you the remaining figures in the set. We would like to leave you with something to think about and wonder about. How is the concept of effective or relative speed used in this word problem similar or different from the concept of relative or effective speed used in the case of a boat moving upstream and downstream word problem?